In this video, I'm gonna take this 2D project and turn it 3D all within GameMaker. We're gonna set up the 3D camera, then add some simple code to make the sprites stand up in 3D, then add shadows on the ground and make the player jump on the Z-axis. So let's get started. I'm in the starting project that just has the player object and a coin object which are placed around the room. You can download this project from the link in the description. Now the first thing we're gonna do is set up the resolution, and later we're gonna do the 3D camera. So for the resolution, let's create a new script. I'll call this scr_res. Now within the script, I'm gonna remove the default function that's already there. By the way, if you're not seeing this exact interface, this is the new code editor that you can enable from the preferences if you are using any of the recent versions of GameMaker. Now in the script, let's create variables to store the resolution of the game. Keep in mind, any variables you create in a script are global variables, so inside of any objects, you would need to use them with the global dot prefix. Now back in the script, let's use the resolution values to set the size of the window, and then use the same variables to set the size of the application surface, which is the actual resolution of the game. Now let's create a new object which will be the camera, so I'll call it obj camera. Let's go ahead and place it inside the room first, and then back in the camera object, I'm gonna add the create event where we're gonna set up the camera and the view. So first of all, to create the camera, let's call camera create view, set the position to 0x0 and the size to the resolution that we set up in the script. The camera is gonna be stored inside the cam variable over here. Now let's set up the view so the camera works. I'm gonna enable the view system first, then set the view to be visible, and then apply the camera that we created to the first view. And now we come to the part that is 3D. We're gonna set up a projection matrix, which is how the camera is set up with its initial 3D properties. I'm gonna create the projection matrix here with the perspective FOV function so we can provide those values. The first argument is the field of view, so I'll set it to -70. Then the aspect ratio, which I'll set by dividing the width by the height. And then the z near and the z far values. This means that only those things that are 3 to 3000 units away from the camera are gonna be visible. And the reason why we're using -70 for the FOV is to make sure that we can have the system set up in a way that increasing X moves things to the right and increasing Y moves things down, which is how it normally works in GameMaker. But in 3D, this is gonna mean that increasing Z is gonna move things towards the ground and decreasing Z will make things go up. Now the projection matrix is set up so we can apply it to the camera we created. Then we want to set up the position of the camera, so I'll create variables for that. These are called the from coordinates, which is where the camera is looking from, and later we'll figure out where it's looking at. So for the from coordinates, the X and Y are set to the player's position, and the Z is set to -200, so that's 200 units off the ground. Now to keep the camera moving with the player, let's add the end step event. So the player moves in the step event, and after that in end step, we move the camera. So here we set the from X and from Y values to the player's position. And then you can add a condition at the top of the event to make sure that this doesn't run and crash if the player instance doesn't exist. Now we want to set up the camera's position and where it's at and where it's looking. So for that, I'll add the pre-draw event. It runs every frame like the draw event, but it runs before any of the draw events are run for any instances, so it's a good place to update the camera. Here I'm going to set up the view matrix with the matrix build lookat function. First of all, we're going to pass in the 3D position where the camera is, so that's the from X, then the from Y plus 500, so the camera is 500 units down the Y axis from the player, and then the from Z. Now we pass the 3D position for where the camera is looking, so that's the from X, then the from Y, but 500 units upwards from it, and then 0, so the camera is looking at the ground. You can experiment with this to get the angle that you want. And then finally we pass the up vector, which is the direction that we count as up, as in towards the sky. So that's gonna be 0 on X, 0 on Y, and -1 on Z, so that -Z is the up vector. And then we apply this new view matrix to the camera. If you run the game with this, you're gonna see that the world is 3D now, even though the instances are flat. So we've got the 3D camera set up, but the background never clears and you can sort of see the smudges. So let's fix that. Go into the room and in the viewport settings, enable the clear viewport background option. This should fix that and it looks more normal now, but you can see the difference in height between the ground and where the player is and where the coins are. This is happening because the depth values that are automatically set for the layers in the room are actually the Z values in the end, so that's why you see the height difference in the game. We want to control the Z ourselves and not let the layers affect that, so I'm going to go into our script that we created and here call layer force draw depth. Enable it and set it to 0 so that all layers by default are drawn at 0 depth, which is the same as a Z value of 0. And then we can draw things at different Z values ourselves. With this, if you run the game, you're going to see that everything is now drawn at the same Z level, and this is what we want for now. With the camera all set up, we are now going to make the objects turn from 2D into 3D. We're gonna do this by modifying the world matrix. The world matrix lets you set up the conditions for how something is drawn, which means not only does it let you change the position of something, but also its rotation. And that's the crucial part here for making 2D sprites stand up in 3D. Let's start by creating an object called obj3d. This will be the parent for any object that needs to appear in the 3D world. I'm gonna add the draw event here first, which is where the 2D to 3D magic will happen. The first thing I'll do is create a matrix in a local variable. I'll set the X and the Y positions to the X and the Y of the instance, then the Z to 0, then the X rotation to -90. This is how the sprite stands up as it rotates on the X axis. And also make sure that the sprite's origin is set to its bottom part, so that's where it rotates from. Then we set the Y and the Z rotation to 0, and then the scale across all three axes to 1. Then we apply our new matrix to the world matrix, so anything drawn after this is affected by the properties we set up in the matrix. And this is where we're gonna draw the instance using drawSpriteExt, so we pass in the sprite and the image index of the instance, and then for the position we use 0 and 0 because the position is already set in the matrix. Then we use its X scale and Y scale, then set the rotation to 0, and then use the blend color and the alpha of the instance. This will draw the sprite in 3D, so now we can reset the world matrix to the default one, which you can get with the matrix build identity function, and apply that to the world matrix. Now because the obj3d object is supposed to be the parent of any object that needs to be 3D, we're gonna go to its parent menu, and first of all add the player object as a child. Now run the game and you will see that the code works. The player is standing up in 3D. Now you go back and add the coin as a child as well, and in the game you will see that the coins are also standing up now. Our 2D game is basically 3D now. The depth sorting, however, is not set up because you can see all the coins behind the player through the player. But the fix for this is really simple. Let's go into obj camera and open the create event. Let's first enable Z testing using this function so that things closer to the camera appear above things that are behind. But just with this, if you run the game, you're gonna see even the transparent parts of the player's sprite are overriding the coins behind. So to fix this, we just need to go back and enable alpha testing with this function, and now the depth sorting is gonna work perfectly as you expect. The 3D part is set up now, so we can work on extras like adding shadows underneath instances. For this, I'm gonna go into obj3d and draw the shadow at the top of the event. We're gonna need a matrix for this as well, so I'll just copy the one that we used here. I'll remove the var part from here because it's been set up already now above it. For the shadow, I'm gonna use draw circle, draw it at 0 by 0 because the matrix already has the position. Use 16 as a radius and set outline to false. I'm also gonna set the alpha to 0.5 and the color to black, and after drawing the circle, I'm gonna reset the color back to its default value of white and the alpha to its default value of 1. If you run the game now, you will see the circle, but it's rotated like the player. So back in the draw event, I'm gonna remove the -90 X rotation part, and now the circle is flat, but it's z fighting with the ground because both the ground and the circle are at a z value of 0. So I'll change the z position of the shadow matrix to -1. The shadow looks good now, but it is too small for the player. So I'm going to change the radius here from a fixed value to be dependent on the width of the sprite. This way it's going to be a bit more consistent with each sprite. You know something fun we can do now? We can draw things at different z values. For this, let's first go into Obj3D, and in the variable section, let's create a new variable called z and have it at 0 by default. So this is the z position where this instance is going to be drawn. To make this work, we're going to go into the draw event, and where we draw the main sprite in its matrix, we are using a z value of 0. So let's replace this with the new z variable. Now go into the coin object, and in the variable section, you're going to see the new z variable. So let's edit this for the coins and set it to -40, which means the coins should be 40 pixels off the ground. If you run the game, you're going to see the coins are now floating in the air, so our custom z value is working. You can also set this for individual instances in the room. For example, I'll put these coins together and I'll set the z for this coin to -70 and for this one to -100, and in the game you're gonna see that they are at their own different z values. And since we have done this, why not make the player able to jump, because we have basically unlocked the z-axis. So let's do that. Let's go into the obj player object and open the create event. We're gonna make some variables for the jumping mechanic. Velocity z is how much the player is moving on the z-axis in the current frame. Grav speed is the effect of the gravity applied to the velocity every frame. And jump speed is the velocity that is set when you hit space to jump. Now let's go into the step event and over here program the effects of gravity. First of all, I'm going to increase the z by the velocity z value, and then we check if the z is above 0, meaning we are below ground. So in that case, we set the z to 0, so it sticks to the ground, and set the z velocity to 0. And then regardless of that condition, we increase the z velocity by the gravity speed. And now for the jumping, we are doing a basic keyboard check to see if the space key was pressed. If it was, we set the z velocity to negative jump speed, so the player shoots up because negative z is up. And then we can also add a check to make sure that the player is on the ground and only then it can jump. So run the game and now you can jump with the space key. Like I said, we have now unlocked the third axis and there is a lot that you can do with this. Now the next thing that we could add to this is 3D collisions and platforms, so that you could build a 3D platformer by say adding boxes at various heights. So if you want to see that in a video, let me know in the comments. And go ahead and have fun with this. Make your first 3D game in GameMaker. Play around with things and look up things in the manual and online so you can understand better. And with that, I hope you have a great day and I'll see you in the next video. Bye.